Yeah, you can go ahead, sir, please.
Yeah, good evening to all our distinguished members, corporate partners, academia leaders, industry leaders, and technology enthusiasts. On behalf of the steering committee and the ecosystem members of SPIN Chennai, it is my privilege and honor as president to welcome you to today's knowledge forum. We are especially delighted to host today's speaker, Dr. Partha Sarathy Iyengar, for what promises to be a deeply insightful session on beyond deep learning, structured and deterministic AI models for industry. So before we get into the specifics of that, I would like to talk about SPIN Chennai for those who are new, our legacy and our relevance. SPIN Chennai is not just another professional body. We are one of the world's oldest spin organizations. About 100 of them around the world are established, and about we are 3 decades of continuous contribution to process quality and performance excellence. Uh, so we are one of the exclusive ones who are associated with the CMMI Institute and the Software Engineering Institute of Carnegie Mellon. So over the years, Spin Chennai has played a pioneering role in evangelizing high maturity frameworks and management systems. CMMI, ISO standards, Six Sigma, Lean, Agile, TOC, Malcolm Baldrige, uh, you name it. We have experts, and we have done some work in that area. So we have been privileged to host globally renowned thought leaders like Watt Sumphrey, who spent almost 10 years with us. Jeff Sutherland, the author of Agile and Scrum, was with us a couple of times. Bill Curtis, he was physically here with us for a Watt Sumphrey Awards. Bill Curtis, incidentally, is part of the uh, core member team who developed the CMMI and People CMM and models. So our membership spans tier one, tier two, tier three organizations, uh, as well as cities, BPM firms, banking, manufacturing, automotive, retail, healthcare, and independent practitioners. So our flagship initiatives like SpyCon, Watson Free Awards, and our monthly knowledge forums like this have consistently focused on one mission, that is enabling business impact through process innovation and digital excellence. So today's session continues that legacy. So coming to the topic, why this topic, why now, right? So today, AI conversations are dominated by large language models, LLMs, GPU clusters, massive neural networks, black box systems. So deep learning has undoubtedly transformed industries, right? Almost every industry has started seeing the huge benefits of deep learning. Uh, so as industry professionals, we must ask, are all problems neural network problems? Uh, does every industry challenge require a GPU heavy infrastructure, right? Uh, because the moment you talk about AI and deep learning and other stuff, there is a huge cost involved uh, in terms of GPUs and other expenditure. So, what about cost efficiency? What about governance, interpretability? How about regulatory safety? Uh, so there are variety of industries like people use sensor data, time series systems, healthcare analytics, industrial control systems. All of these need stability, reproducibility. explainability, very, very important one in this AI world, and deterministic outputs, and CPU efficient deployment. So this is where today's topic becomes extremely relevant beyond deep learning. So it doesn't mean that we are rejecting deep learning, right? It means maturing beyond the hype, right? Choosing the right model for the right problem. Just like we have so many GPTs, no, models, we have Dr. Partha brings what is called Spectra LDA, which is more like Atmanirbhar, while all the other things are all, whichever you talk about, Claude or, no,
15% import duty.
yes, that is a, people are not sensing the cost, but already they have started charging. Everyone has, after the few free credits, everyone has started charging huge money, right? So this topic is not just academic, it is very, very strategic. So it aligns perfectly with the SPIN's DNA in terms of structured thinking, measurable systems, and predictable outcomes, and Atmanirbhar, right? Very, very important. That is where the Spectra LDA, what Dr. Partha is going to talk about today, has high relevance to India as well as SPIN Chennai and members. So I think it is a no-brainer that this is going to help the engineering teams. It is going to, CXOs and decision makers, process and quality leaders, startups and MSMEs, right? How to, one of the important takeaway for them will be how to build intelligent systems without heavy GPU investment, right? Dr. Partha is known for his cost-efficient techniques. So he will bring about, elaborate on more of that. So how to deploy interpretable AI,
I
how
think
to
you
move
remember
from,
our virtual expos.
yes, 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 yes. During COVID, I think, he brought out, platforms, virtual exhibition platforms, and which helped not only conduct classrooms for several universities, but several conferences, several events were conducted on his platform, right? So, in essence, this session will help us move from AI excitement to really AI engineering maturity. So that is what precisely SPIN stands for. So coming to Dr. Partha, he is the CEO and co-founder of IS360 Technologies, uh, and he straddles between Chennai and Pune, Bombay, and all the other parts of India as well. So he is a AI systems architect, signal-centric AI researcher, and a deep learning strategist. So what makes Partha's profile unique is the intersection he operates in, right? AI, deep learning, signal processing, and enterprise scale intelligence systems. So he brings a beautiful intersection of all of these technologies, and his work spans interpretable AI and hybrid architecture, spectral and signal centric learning systems, EEG and brain computer interface analytics, feature space optimization, discriminant modeling, AI governance and maturity modeling, digital twin and adaptive AI systems, edge AI telemetry, and drift aware learning. I think, phenomenal experience he brings to the table. He has contributed to more than 20 patents across domains such as interpretable AI systems, AI governance architecture, neuro data processing frameworks, hybrid edge cloud intelligent platforms. He has authored and co-authored multiple advanced technical books across AI, machine learning, neuro data systems, BCA engineering, all of those. So he's known for advancing mathematically grounded learning systems that bridge statistical theory with modern AI pipelines. So in a world that often celebrates black box complexity, E brings clarity. I think in a market driven by scale, he emphasizes structure. In a time of hype, he brings engineering rigor. This is exactly the kind of voice SPIN Chennai values. So, as president of SPIN Chennai, I strongly believe that these sessions like this elevate our community from being consumers of trends to architects of sustainable systems. So, let us engage deeply and interact with him, question thoughtfully, and learn from what Dr. Partha has to say. Please join me in warmly welcoming Dr. Partha for today's session. Maybe you can unmute and give him a big hand. Dr. Partha, the floor is yours. Thank you. Thank you very much.
Thank you. Thank you. Thank you, everyone. So, thank you, Dr. Rajaraman. And of course, my friend Srinivas, of course, my co-founder Satyanarayana, who has joined me today. And of course, I don't see her, but one of our close associates, Ms. Prema Mukilan, she should also be there. She is also a close associate of IS360, and of course has got some skates in the company as well, and always been supporting us during the time of stress and drift and whatever it is. Okay, so I thank you once again, and then would like to start the evening with the emphasis that I'd like to add a few more abilities what Dr. Rajaram told. More than sustainability and everything, we insist on accountability. That one ability we insist upon that. So that is the reason that I came up with a separate model called Artificial Intelligence Maturity Model, where this ISO standards end, our AI maturity model begins. It is not just another CMM model replications where people just get carried away and then say, no, we have done this, we have done that. A lot of maturity models have come up, but our model has a unique self-learning model and which can be mimicked in any different scenario. Of course, as the time passes, I'll be able to share more details about that. So I would like to make it more interactive than as a simple presentation. So with all your permission, and I'm just going to share my screen and then would like to go ahead with that. Okay. Is my screen visible to all?
Yeah, it's coming up, sir. Yeah, you can put it in presentation mode and start your session.
Yeah, of course. Just allow me a little time.
Sure, sir.
Because my bandwidth is a bit low. Maybe if you would allow, I can mute my camera also. So I think my screen is visible now.
Yeah. It
Yes.
is.
Okay. I think most of you might have attended the recent AI conclave that concluded in a grand manner that our Delhi and of course our Honorable Prime Minister was a very close participant and a contributor in so many different aspects, and he had made sure that lot many things happen over there, and then people get involved in a great manner in that. I was also closely observing. I didn't have the opportunity to go over there, but I was closely observing. But some few questions came up in my mind, which I spoke to Dr. Rajaram also in the evening. Okay, so I think I can start the session with those questions to you also. Is AI today a technology platform or a cost problem? And most industrial AI deployment start well, but on the scale, then the cost rise sharply, they get stranded. So what do you think that it is the cost factor that is going to make a difference, or the technology deployment is going to make a difference? And we are certainly at a crossroad. So do we keep thinking and keeping larger models, or do we design smarter and architecturals? That is the biggest question that I would like to have. That okay, so the larger models are the uh, best smarter architecture. So that is going to be the main question over there. And as you told, like the GPU dominant architecture are becoming a cost intensive. Dr. Rajaram was telling that you have to pay through your nose. Okay, but everybody talks about AI. Everybody talks about deep learning and everything. But how, at what cost? And is it a real world system operated, or it is like a sensitive environment that we are going to work where it has a lot of noise? When I say noise, not the physical noise in decibels. The data, once you start gathering it, it comes with lot of noises. We have been very closely working with the EEG data sets. We brought data sets from so many areas, from our Temple University, hospitals, and different places. But when we found that most of the data set from Wang, China, it had nothing but noise. The EEG data, it started with 16 electrodes, then 32 electrodes, 64 electrodes, 250 electrodes. Now they talk about 1024 electrodes. We're going closer to the point and then gathering the data. That is okay. So much so you are creating the noise. What is the key component you require? As the research we have done very carefully and very in deep, I observed that we require only 5 points from where I had to gather the data. The rest of my 27 points are only creating the noise. Okay, and scalability now means it is an economic scalability. Where do I deploy? I prefer nothing less than AWS. I got an initial credit of say $5,000. But as and when the traffic increases, when more and more visitors come, what extent visitors use it, I am going to pay for it. So at what cost we are paying it? So we require a cost stable intelligence. That is the prime interest that we have today. So the industry where it stands, that is in front of you. GPU dominant architecture. Real world systems operate in noisy and drift sensitive environments. Scalability now means economic scalability, and the need for cost stable intelligence has been felt very deep. One example that I can bring over here is what Nandan Nilankani spoke in that conference. He was all praised to Prime Minister for deploying this dairy and cattle's model in just 11 days. They have been working for years now, but it got rolled up there in 11 days. But I am quite sure it is going to have a headache for at least 11 years up to come. Yes, government can pay the cost. Can an entrepreneur afford it? Suppose somebody wants to come with the same project by deploying all these IoTs and other things right from like, growing the fodder and everything, where from the fodder comes, whether it is organic or not. All the cows are being fed and only that they graze only this organic grass. So without any steriles, and I think they are giving the organic milk. So these are all the biggest questions over there. What milk we drink today, it is all powdered at least 2 years back. So who is giving the original bottled milk? If a person there, like I know somebody there near Maduranthagam. That gentleman scaled up from 300 liters to 3,000 liters. But he got the funding from the angel investors who are sitting on his head right now. They don't allow him to go and borrow from the bank, and he's not able to scale for the last 2 years. That is the crossroad that he is there into. Can he implement these AI systems and other things and go? That is a big question now. So what industry actually needs is deployment beyond laboratory and data sets, then continuous operation under drift, regulatory compliance, predictable operational expenditure. When I say regulatory compliance, it is there with the governance. Governance with the regulation has an accountability, as I told you, other than the security. Okay, and it has to be a traceable mechanism over there. How many of the AI systems are traceable? That is one big question. By the time you start deploying or duplicating some system, some new problem arises, and what the amount of data you have incurred by then and the system what you have trained, that is going to be obsolete. So the deep learning becomes dominant as of now, but it comes with a number of inherent problems along with it. The high parameter capacity and the GPU acceleration and parallelistic optimization and infrastructure growth, what are all the things that it came along with that. Now it has got exponential problems related to all these aspects. Of course, the GPU acceleration, it has its own cost. Can I afford Claude? I am a startup. So can I afford it? Or will any of the CNN OpenNet tools is going to serve my purpose? That is the biggest question. And you need a very large training data set for which you need an accountability, and you need to have a total undertaking that whatever data set you take, you are not going to do any infringement with the personal data of the provider. Suppose it is a medical condition, the particular subject, that subject entire secrecy is to be maintained. So how my data set is being coded and how it is being carried out all through it. It is the biggest question over there. So success, it's a complex task as of now that. The more than everything, the hidden cost curve, as I was telling in the beginning, data growth is deeper models. Deeper models go into higher compute. Higher compute is a scaling cluster. Scaling cluster need to MLOPs, and it has got its own overhead. So it is a vicious circle now. So where from we start and which point we do discuss? Can any one of you remember that these points were discussed there in the AA summit? Did any soul bother to discuss this particular case that, okay, the startup who is going to adapt all these AI, deep learning and other things, they are just able to manage all these things, hurdles? That is the biggest question. But the real task is when the model leaves the lab, there is a biggest headache that is going to face immediately. The day one or at least the nth day is the biggest problem of drift. Simply means that data you see today is slightly different from the data you trained on yesterday. It is not even yesterday. We have got data even from 2013. How relevant it is. Okay, so that is the biggest problem that like, okay, all the in the healthcare it is still more worse. There is no accountability. All the laboratory data what we are receiving, there is no proper tagging, there is no proper data alignment over there. I cannot take it up as a direct input to my system. Lot of pre-processing and processing I need to do. As time series Dr. Rajaram was talking about, the biggest task is eliminating the noise. And some data come with 60 hertz of data taken there in different countries. I am following 50 hertz over here. So how do I manage it? So the environmental variability and population heterogeneity is again a very big problem over here. So the real world environments versus lab conditions are totally different. Everything there is overhead for data drift, process changes, anomalous inputs, and cost escalation. Everything has a cost. And the problem is geometric instability in high dimensions. What algorithms we have as on today is a mean shift. It is a scatter inflation. How do I control the scatter? I draw a boundary, then calculate the mean, and I implement my model. That is the very simplest model I can explain to any layman, which I think we studied there in class 12 or something like that in the statistics, mean, mode, variant, all these things. Okay, so the boundary you need to rotate it. Once you rotate it, then only the single dimension can become a three-dimension data, where it can be brought into a situation where these scatters are limited. As long as you are able to bring the scatters very close to your mean or your tangential line over there, by the time you bring it, your separation collapses. Because I am working hardly on two variables. What happens in scenario when you have multiple variables? Do we have the system to work on multiple variables as of today? If anybody practicing it, you can answer it. I can make it as a very beautiful debate over there. Nevertheless, we can take it up towards the end of this session. So that is the biggest bottleneck the system has got. And no soul has bothered to bring up those problems. So the geometric instability in high dimension is the very big problem over there. And the separation challenges are going to be very big problem. You cannot limit the boundaries and say I'm going to work within this only. More and more data increases, your numerator is going to increase, not the denominator. So by the time it is going to expand exponentially. So we need a system which can automatically increase the denominator and bring the boundaries much closer and still stay a separation stronger. So the geometric uncertainty needs to be addressed first. So that is the scenario now. So the geometric instability has a cost consequences as well. Drift refining cycles, then the covariance inflation, numerical instability, which needs to boundary rotation and re-optimization, collapse, then re-architecture. Then you go for the retraining. By the time you go for the retraining of the system, you found that the algorithm what you worked was an obsolete. Because we are not researchers. We take only the formula or the algorithm available there, or the service provider tells us, and we get up onto it. So we need to get into the fold of researchers like maybe Dr. Meenakshi and or Anna University and the forums over there. And the industry has to work very closely along with that. So even the startup ecosystem has to extend their boundary and get the people who are involved in the research, not just buy the licenses of the research or the patents or something like that and try to copy it. It has to be an ongoing process basically. As the business grows, your research should grow. At least some 30-35% of your revenue should go to the research. Then you go along with that and you work very closely with the ground realities. So that is the biggest challenge that. So the complex geometry it has got a cost link directly. Cost escalating computer resources, and not to talk about the data services what you are hiring. I remember to have started my unlimited data service by our friend Ambani's. Initially, they are providing it free of cost, unlimited. If you all remember, way back, I think in 2016-17, if I am correct. Now, for the same plan, I am paying something close to 1,200 rupees per month. So it is a slow poisoning, and people are not aware of it. So as long as I get into a scenario where I just walk into an incubator like Anna University or somewhere else and enjoy the system, that is okay. As a startup, it's okay. But when it comes to the ground reality where the models grow up and the company grows up, I need to rethink the intelligence architecture. So the solution is not deeper models, but it has to be a controlled geometry. And unfortunately or fortunately, none of the models in current day are geometrically controlled. They are only vector controls. Either 2 by 2 is a scalar vector, or it's a multiple matrix like neural networks, what you have got. It is only a vector matrix. Nothing to do with the geometrical controls. So the structured features engineering, spectral signal analytics, deterministic discriminant optimization, capacity bounded modeling. This is the architecture one has to come, and the paradigm has to be shifted very drastically. And as I told you in the beginning, the paradigm should have structured data, cost scalability, interpretability, and determinism. Apart from structured deterministic AI, it has to a high dimensional instability with geometric and cost stable intelligence. That is the best model that I can recommend to anybody basically for that. Do we have any such model? Have any of one of you come across that? As I go to my beginning of the presentation, I'd like to discuss some of the untold stories, what none of these people, including our friend Sundar Pichai, who was boasting about the autonomous vehicle in which his parents went around this Google infrastructure when they visited their US. He was very, very happy and he was all compliment to the technologies. But there are lot many untold story which I'm not going to cover very drastically. I can cover one or two stories in a very simpler way without going beyond my purview and then not crossing my limits. We talk about lot many GPTs. So Chat GPT, OpenAI, it has got a massive GPU cluster and it has the continuous retraining model. And the cloud redundancy is very, very, very heavy over there. How many of you faced it? You are not training open this chat GPT. You are only utilizing it. If anybody had trained chat GPT, then you can face the problem. What are the limitations that chat GPT has got? Likewise, Uber. So hundreds of models in production, feature store scaling, dedicated ML ops. But along with that, the biggest challenge is they want to go autonomous. And if they want to go autonomous, telemetry is the very biggest challenge. As the telemetry comes into the picture, one interesting point is a last mile intelligence. That is the best suited intelligence that has to. Before taking any decision, my system should think on its own and then say whether I can offer this solution to the person or not. Then only your autonomous system will succeed. So, the microcontroller, what you are going to use over there, it just cannot take the instructions and pass on like a washing machine or something like that. It has to be a little more intelligent. Maybe in future days, who knows, it can mimic a human being and then come to a very realistic situation. That same thing there with Netflix and lot many financial services. Okay, so auditability and explainability, they are facing a very big problem over there. Model governance is a very big problem. Compliance logs, nowhere it is gone. Once your data goes to any financial institution, just for an analysis of your CIBIL, you had it. N number of callers will call you and they will offer so many things. It's a fact that everybody is facing that. Where is the governance? Where is the compliance? Then what is the point in doing everything that's an automated system and like, okay, just feed in your data. Within 2 minutes, your loan will be sanctioned. Within 1 hour, it will be dispersed. It's all there. But RBI is not able to govern it. They are not able to control it. So much so, there is a huge data breach and lot of online theft and a lot of phishings, so many things. So that is happening day by day. And most of our Bihari friends are much happy nowadays. So the way you find out something before that situation comes into the market, they are there with the solution to break it and come with a newer solution for that. Everything they have a solution. So the intelligence works better there than the people who are implementing it. So AI cost exposition after initial success is has got the 5 hidden drivers behind the escalations: latency, model drift training, telemetry monitoring, then the compliance governance and the infrastructure expansion. Okay, so the when I say telemetry, when you go for the autonomous system, we had seen lot of green cycles. Even if you go to IIT, I think it should be still there. Okay, so how many cycles have been stolen? There is people who can definitely break it. And the observability is the biggest stack over there. That layer is definitely lagging over there. And then the metrics retention and the trace the storage where the data gets stored. So the next time when a, a driver, I mean the customer gets into the vehicle, maybe boards there in the airport. So the your system should be smarter enough to understand where all he goes there, and it can directly drive. Of course, we Indians are not bothered about that as of now. It is going to take a sweet time. But at least people have got dreams. Okay, they talk about autonomous. But how autonomous is being governed? How safe it is? So that is the biggest question over there. So the real world cases, as I told you, I think we are going back. I'm sorry. So at this place, we come in with a greater solution. That is our Spectra LDA, as I was telling about, which is working on a mathematical core problem, which is geometry oriented, not just vector oriented. So it is between class of scatters. When I said scattered data sets are there, we are working between class of scatters and we are working within class of scatters. It is a contradictory statement. We are working between class of scatters and we are working within class of scatters. How it is possible? So I can just explain in two ways. Suppose you have two classes in which you are working upon that. We treat it as an ellipsoid where we create a scatter over there in the form of ellipse and then we rotate it around the line axis between the two foci and we rotate it and we take a common point which is rather perpendicular to each focus and we draw a skew line. Each focus for me are skew line, that is they neither intersect nor parallel. So I take a mean over there which is perpendicular to each. So on the scatters which are there in the ellipsoid of the other two classes and I map it and I bring it as a scatter to my resultant vector over here. The output of two classes are going to be an input variance of my new scatter. So that is my new diagram. So now I am going to trace another ellipsoid over here. I'll try to bring in the scatters closer as much as possible and even if possible make it as a zero. Ask me why, I'll tell you. I don't know, but how far people are following it very technically over this discussion. It may sound a bit crazy also, but by the time me and Satya discussed, I said within 10 minutes I came with the model. Yes, this is what the model we are working upon that. So people got more enthusiastic about that. We started discussing with NRDC, that is our National Research Development Corporation. So they are very keen to buy back it, and then they are willing to map it and do it so far. The thing is, you have a better technology over here, that it is a resultant of, rather I would like to repeat again, it is between class scatter and it is within class scatter. So that makes it very simple. So this is the drawing of that. So I maximize the separation while stabilizing the structure. I have two variants over here, that is B stabilizes the structure and A maximizes the separator. A is my resultant vector. This is going to maximize the separation. I am trying to gather more and more scatters there in the two resultant structures, and I am trying to bring them together. That is the concept over here. So it is geometrically feasible, geometrically stable, and geometrically unlimited. I can go 360 degrees of my vector A. I can go 360 degrees of my class B. Class A, class B, 360 combination of 360. Apart from that, you multiply it by another 360 degrees of my own segment over here. So it is going to be mind-boggling. So I am not bothered about the limitation of data. Whatever data it can come inside, we can gather it, we can scale it, we can create a stronger system which is much stable. How it is cost behaved? No parameter explosion. You bring in as much as data possible, it will not explode. I am not going to use GPU. If somebody is there, you can clap your hands maybe if you are happy. It is a CPU sufficient deployment. No deep learning cascades. I'm not going to do multiple cascades and then doing a deep learning. This is a linear cost growth. There is no cascading. There ends everything. Don't require GPU. That is as simple as that. So, this is the cost behavior. So, that is those who are there in GPU, we strongly recommend shift to SDA and you get a high D from low D spectral space. Okay, the high density. It is a conical figure that it can gather the data and then bring it over here, and it can go towards my particular vertex of the chronic cone, then make it as simple as that. Okay, there is no complex geometry. It is not a volatile, expensive scale. It is very stable, interpretable, cost efficient, interoperable. That is another interesting situation. Here comes our artificial intelligence maturity model, which is another invention we talked about. We are deploying this concept into a twinning concept. We learn from this particular model because this is governed. That governance is my seventh layer, other than the 6 layers, what CMM or anybody else talks, if you are aware of that 6 sigma, beyond that. My seventh layer is, of course, the governance. Because of that, I can go and replicate anywhere where the system or the process is similar. As a virtue of it, one simple case study I can tell orally over here is, you have seen green hydrogen, which is biomass based green hydrogen. That is, I talk of the town now. Government want to get into that. But biomass generated hydrogen is very, very, very costly. Whereas I can train that particular system, then I can replicate it in a typical solar operated green energy, green hydrogen development scenario, whereas the solar system can be trained and as if it is behaving in such a scenario that a biomass based situation is working over there. As a result of this, okay, the electrolyzers, what they are using it, normally the life is 35%. It can be increased by another 30% minimum, so that it becomes somewhere around 47% or so. By virtue of it, the cost of generation comes down from, let's say, 140 rupees to somewhere around 95 rupees. That is a very, very, very optimistic figure that I can pass on to this. One typical scenario I can give it to you. Another scenario where we are working as of now is train the system with the human, what you call as a kidney. And we have developed along with bionic kidney, which we are going to train as if it is going to work in a scenario of a human kidney. And the best part is there is no tissue mapping required. It can either be fitted inside or fitted outside. And the very, very tentative cost is somewhere around lakh and 50 rupees. That project is very much under development. So what works this is the posterior ambiguity zone. You might have seen the Venn diagrams which work there in the normal CNN or any other model which works. We talk about the Venn diagram where too many parameters intersect. That portion, we are calling it as the mean that we are going to work upon that. So I am talking about two ellipsoid intersecting each other in a very specific scenario where the scatters are very optimum. That particular area where they are getting dissected or intersecting each other, we call it as a posterior ambiguity zone. We call it as PIZ. That is the overlap of covariance ellipsoids. And quantifiable instability region it is. The instability region which can be quantified. And drift visibility in projection space. The drift is visible in a projection place, in a plane. Because of that, I can work out on either side of my line where it is getting projected. So whether it is a minus or plus, I can work out the mean and bring it as the best mean possible for the scenario. So easy intervention triggers over there. PAZ has cost control layer where it stabilizes the geometry instead of expanding the architecture. Controlled recalibration. Recalibration can be done by itself and avoid unnecessary retraining, and prevent infrastructure scaling, and maintain economic predictability. It is close to 95% prediction, not like 75 or 73 or 80s or whatever it is. It is close to 95%. The more data is standard, we can go closer to 100% as well. That amount of care has been taken over here. So the posterior ambiguity area is the brightest spot. As the question mark you can see, the dotted line is my posterior ambiguity zone. Class A and class B, as I told, these are all two ellipsoid on either side. Okay. I think this particular architecture might have given a very fair idea of what our spectra LDA is and how it is geometrically stable. So it is a deterministic AI in the industry. Structured AI fits industrial realities like biomedical signal systems, industrial sensors, geospatial intelligence, financial anomaly detection. Okay. So these are the four major domains that it can best serve as of now. And not to quote about your EV. EV is a very small part of your manufacturing domain. Process stability, as I told you, we are going to work with a major university. Rather, it is, I cannot call it as a university. It is a PGDM college from Bangalore on agriculture. So they are willing to sign up with us in the agricultural projects where the IoTs and other things can be, data can be gathered, and on the spot it can be trained and it can be interpreted and given back to the system. It need not travel to the cloud and then the calculation or calibration needs to be done. What I need to do is only the calibrate the things as and when some update is there on my the edge microcontroller. That is the only my cloud bandwidth is going to be. The rest of the things are autonomous. Everything is going to work only on the ground. So my cost to my dear friend Amazon, of course, is patterning us. I should not say that loudly. So the process stability and quality control comes into automatically. Low error rates, mission reliability, financial risk control and cost efficiency, signal stable diagnostics, and everything. So the strategic economic advantage, as I told you, reduced cloud expenditure, low GPU dependency, I would say even zero GPU dependency, simplified governance and sustainable deployment model. When I say simplified governance, I am adding up simplified traceable governance. That word has been missed over there. Sustainable deployment models. So the deployment reproducibility is not going to be much heavier. And scalability, cost stays low as scale grows and handles large data sets, adapts to growth, efficiency, less resources needed, linear computational scale, and no overhead retaining. You need not retain the overheads time and again. Sustainable growth is there, predictable cost that is there, and future proof stability is there. I can assure that for so many years it is going to be stable. So the predictable cost, as I told, is I know after 2 years what is going to be my renewal charge, what is going to be my, network cost, how much I need to pay for the CPU I am using at the server. Everything I know on day one. So I can plan everything and go in a systematic way. So the future stable, governed, structured AI. From separation to stabilization, from black box to transparent geometry, Dr. Rajaram, you mentioned about black box. From compute heavy to cost stable systems beyond deep learning. So the same thing, stability, governance, structure. So here it's a simple comparison of multiple APIs. So Claude is one thing which Dr. Rajaram asked about before starting this session. So the result is we can see how many tick marks I have got. And the transformability and other features. Nobody else promises the geometry over there, and nobody else promises the few thousand lakhs as the permanent size. Parameter size is not confirmed, and I am going to work only on CPUs, not on GPUs. And the training cost is very low, and inference cost is again near to zero CPU, and interpretably is low in the case of Claude, and it is low medium in deep learning, and it is very high in our case. Then the drift transparency is not possible in Claude. It is opaque. It is hard in deep learning. So I can provide a very clear, transparent drift by mapping it on the line which I am going to use in my PAZ. Retraining cost is hidden. It is high. It is low over here. I don't say there is no retraining cost, but it is considerably low. You need not retraining once in 2 months, 3 months, as long the data keeps growing. You work in one particular geography today, maybe in rurals you have worked. Then you go to urban area, your entire paradigm shifts, your paradigm changes, you need to retrain. Maybe from urban, rural to, you need to go to the interior and go and work with the tribals. Then again your data behavior changes drastically. So you need to bring people from tribes to the mainstream. That is the policy of the government. So scaling behavior is cost grow with usage, cost grow with infrastructure as far as the deep learning is concerned. It is a stable cost. Here is something very interesting. I have used only EEG nets because as of now we are working on the EEG data sets. So practically we have seen that per cost hour is something around $60.66, whereas it is coming around $0.03. It is very meager, throwaway cost it is. We have already recovered our invention and research cost. So that's it from me. Any questions? I am answerable. My contacts. So that's it from me, friends. Over to you, Dr. Rajaram.
Yeah, Partha, that was a fantastic exposition of your model.
Yeah.
So
Any
curious to
questions?
know who are all using it, started using it, and what are some of the findings?
Sir, we are at the lab level. I am telling you, I am using it for my NeuroSync. Okay. We have just filed the patents. Patent has been just published and it has not been granted. We are, of course, working along with NRDC So they are working on the TRL level also. We are open for any open trials and we are open for any synergy. So much so. If Anna University for this bio department, they want to work along with us, we can work. We have ample experience in working in EEG datasets as well. So that is also possible. As I told, 5 paradigms already we worked, and one pilot we did it for this EEG dataset is for a 6-month-old child, okay, which lost the hearing. It had a hearing, but got impairment due to some infection from the outside. The child's father is from Air Force, so he came down from Delhi and put his cloth along with this naphthalene ball there in the cupboard along with the child's cloth. So the child developed very chronic viral infections and other things. So it lost the hearing. The entire medical fraternity declared that it cannot be revived. We took the challenge, we took the EEG datasets. We proved practically that at 13.5 hertz, the child auditory things can be simulated. So we have proved it practically also and mapped it on the skull and proven it also. So now they are working with the ENT specialist. So that much is the laboratory experience we have got. But end of the day, we are also a startup, sir. So people like you should take us to the World Forum and say, yes, here is a brand which can grow with anybody.
Yeah. So for startups and the industry people, how do they work with you? Like, what are some of the starters?
It is mutual, sir. It is mutual. Let them work. We are open. We are very, very, very open. We are open to work on OGL only. They need to pay for my license. My vehicle is free. Only they need to pay for the petrol. Wherever they want, I can travel along with them.
Well, what are some of the use cases they can take up initially?
Anything, sir, no limitation. Agree, they can take up EV, they can take up energy, they can take up production, general industries, they can take up automation. Wherever IoTs are being used, I can go as the last mile connectivity and provide them the micro sensor to get the answer and answer the IoTs on the spot. There is no centralized CPU required. As I told, 5 BCI paradigms, we have created a large kernel over there. And these things we have tried and brought into a chip. And that is fitted there in the robotic leg. So person wearing this Bluetooth enabled headphone, he is controlling his leg. He is walking. That is a typical use case. And it can be used vice reverse also for the rehabilitation of the patient. It can be worked. So the scope is very vast. Alzheimer, it is treatable. I think Satya, you can explain that Pune case, maybe if you are interested.
Yeah, it's called deep brain stimulation. Yeah, my name is Satya. I am a developer working with Partha sir. Okay, in IS360. See, we worked with a doctor. Okay, we don't want to disclose the name of the doctor in the hospital, but the application is called as deep brain stimulation, where for a Parkinson's disease, a patient, for example, I'm giving one use case, a patient is a general from Iraq. He has come from Iraq to India to Pune where he is suffering from Parkinson's disease. Since we are all Tamil, I use the local language. Okay, காக்காவலிப்புன்னு சொல்லுவாங்க நம்ம இதில். Okay, it's a surgery. It's a neural disorder. Okay, he's suffering from there, and we use implant which is allowed in India. Implant for uh, for helping the pressure point of the patient to be controlled through that. See, we are not doctors, but the technology which is what we have given for measuring the rehabilitation of the patient who has undergone this particular surgery. Okay, and within 1 hour of the operation, the patient who's a general in Iraq, who's suffering from this, who's suffering from the Kakavalipu, he got the rehabilitation and cure within 1 hour of the surgery which is done. And post surgery, the doctors are measuring the progress of the patient through this DBS which we have given them, deep brain stimulation. Okay, that is to measure the signals of the brain. And the other things which Partha sir was saying, the other use case is called Medline Robotics, which is an hospital in Chennai. Okay, which is for child care. Okay, pediatrics, and for the doctor who's associated with us. So we developed a technology and we have given, and that we have able to get for a patient to get we got the brain data of the child and suggested what is the issue for the child with which a normal EG could not detect in India. Okay, we were able to detect with our technology, with our spectral LDA, and we have told what it is, and the doctor, see it we are not replacing the doctor. It is an assistive technology for the doctor. The doctor takes a decision. Okay, the AI, the LDA is only an assistive technology for the doctor. So these two examples from the healthcare, we are working very closely with Anna University, IT&T, for IRS, Institute of Remote Sensing, from Anna University. I think one madam is here. Okay, we are using AI for geospatial information to find out the for water management. Yeah, good to know, sir. Yeah. Thank you, ma'am. Thank you, Dr. Meenakshi, ma'am. Okay. So we are able to work with the IRS, and we have given a solution not just for the mapathon, but also how AI can be used for the future in terms of rasterization of the satellite informations which they have given. They have given these information of the satellite for 3 different seasons to find out, okay, in which what satellite image we have to use, so that the government can find out in the upcoming seasons how much of water they can establish. They can predict that the reservoir will be available in the. Okay, so that is another use case. That the another use case what sir was saying is for the EV, electric vehicle, for the safety of the driver using the neural headset. Okay, that is one use case which we have developed. So there are multiple industries for which we have given solutions from spectral LDA. Okay, that is from IS360. Thank you. Is there anything, sir? Partha, sir? Right. Anything, Dr. RV?
No, I think, you gave a fantastic elaboration.
Yeah, thank you.
Yeah, we'll wait for others' questions. Srini, any other questions have come up?
No, sir, not yet. So, Partha, sir, I actually have a question. We are working on a NVIDIA GPU. You didn't mention about how it gets better with respect to geometry and
I know that. That's why I didn't drag in NVIDIA over there.
No, we are actually using the HS100 for this is actually for a image to 3D concept wherein we are using the GPU and the virtual system there. Is there anything that we could do? This is mostly for 3D model generation and optimization over cloud. So is that something that the your model or the solution can work or provide support in terms of the company?
Over to you, Satya. It is his laddu.
See, for the human brain, see, I'm not comparing, so which is good and which is better and all these things. I'm saying the features which we support. See, in epilepsy detection, okay, it requires the brain to be the three-dimensional part of the brain has to be analyzed and to find out where the seizure occurs at a point in time which is recorded by the doctor. Okay, so our model, see, I can show you the model, not now, it takes some time because I have to set up a system offline. I can show you, okay, where. So we have used our model to find out the seizure at the nanosecond of what is prescribed by the doctor. It is done based on the data set which is given by Freiburg Center of Epilepsy from Germany. Okay, they have given the data set, and these markers, biomarkers, are recorded by the doctor, and which they it was not able to be detected by normal EEG, but through our application, we are able to identify the epilepsy seizure and give it to the doctor, where the doctor is able to find out where at this point in time, at this part of the brain, using 3D analysis, okay, the seizure has happened. I can show you here. Yeah. Any questions, sir?
I think that answers your question, Srinivas.
Yeah, maybe I'll just check it out.
Yeah.
So thank you, Dr. Meenakshi, for your time over here. Any specific question or interest? I think she has left. So customary thanks, Dr. Rajaram.
Yeah, thank you very much. Srini will propose the vote of thanks.
So I think
No
we have
problem.
one
I'm just
question
thanking
here.
you. Yeah, please.
Has
Yes,
SLDA been used for image data? This is from Ahmad Rizvi. Mr. Ahmad, you can maybe unmute yourself and ask your question.
So, from our age, so we are working with primarily image data. So, I was wondering if it feels like a machine learning approach to me. So, I was wondering if the image data can be done with SLD.
that's what I told you. We are working on breast cancer. We require some MRI data. It is best suited for image data. Okay, and that is the same question, of course, Srinivas was asking. Image data only we work for this GIS system. processing the images, and we found out the water level of a reservoir. I think the reservoir was somewhere inside the IIT campus, what the data set they gave. What exactly you do, Arvind?
Yes, Mr. Ahmed.
Ahmad Rizvi.
Yes.
Ahmad, is it?
So,
Sorry, Rizvi. Yeah, sorry.
okay. So we so there will be like image data classification, object detection, those kinds of things we'll be doing. So that's what I was interested to know.
For which health condition it is?
So it is related to industrial visual inspection, not necessarily related to medical image data. So that
Yeah,
might be.
it can be for even like it's for buildings where these cracks and I think they detect, using the photograph, they go there, and bigger structures, they go and take the maybe the X-rays and work upon that. So that can be done using the X-rays. If any future breakdown can be predicted. Suppose the old aged plants like okay, yeah, these Madras refineries, Madras fertilizers, and so on. So those X-rays can be digitized and it can be worked out. The prediction is the biggest way of avoiding the accidents. So that is definitely possible over here.
Thank you. Thank you so much. Check it.
So, any other questions from participants?
Maybe you can send me the recording, sir. I think you.
Yeah, sure. It will be
Yeah,
uploaded in
okay.
YouTube, sir. I'll send you the YouTube link as
So kind of you. So thanks, Dr. Rajaram, from my side for the opportunity. Looking forward to working with you very closely.
Definitely.
Yes. Yeah.
I think Spectra LDA definitely deserves a serious look from all the Indian companies
No,
and
even in
startups.
your railways, as we discussed last month also, no?
Yeah.
Lot many cases we can work along with that. Spectra LDA twinned with the AAMM.
Okay.
It is going to be the real game changer.
Okay.
Okay, so we need one break. That's it. One that breakthrough is achieved, and definitely we can prove ourselves.
Sure.
So
Yeah.
my
Considering that it is a Atmanirbhar product, I think it deserves more attention. Right?
correct. Make in India.
Yeah. Thank you. Thank you very much for the
Thank you very
insightful
much, sir.
discussion.
Thanks.
Yeah.
It's my pleasure. Okay. Anything else, or
That's it. No. We'll regroup later with some other
yeah,
opportunity.
sure. Yeah, thank you everyone, and thanks, Mr. Partha. Thanks for this, taking your time to be with us on this session today, and thanks to all the participants as well, and thanks to everyone from SPIN Chennai.
Thank you.
Thank you.
Thank you.
thank you.
Thank you, Mr. Satya.
Yeah.
Thank you. Thank you, sir.